Okay, so we were supposed to handle outcome 3, and on outcome 3 we are supposed to apply modeling techniques to communicate the requirements for an information system. So, and applying modeling techniques to communicate the requirements for an information system, we are going to begin by talking about the different categories of requirements that a project may have. A project may have different categories of requirements. So, what are these categories of requirements that an information system project may have? And we need to ask ourselves the question, why should we care about types of requirements? Why should we care about types of requirements? So we have different types of requirements. We have functional requirements, performance requirements, internal interface, etc, 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 etc. Now, the functional, performance, and external interface are actually the most important functions to three roles that we actually looked at in system engineering. They are important to the requirements analysis role. They're important to the specification writer role. They are also important to the designer role. So for us to have the requirements analysis have actually, when we look at the requirement analysis, we need to actually look at an existing close relationship between the types of requirements that is actually going to handle and the specific analytical techniques that are going to be used to handle these various requirements. So the analyst is going to benefit greatly if he understands the different types of requirements that are there, the different requirements, and so that he can select the most appropriate combination for the techniques that are actually there. Now, to be able to communicate about the requirements, their capture, their validation, is going to rely on the good understanding of those distinct differences. Now, to the specific writer, uh, uh, we have all the influences on good requirements and specification. Both structure, the type of requirements, will be of great influence. Okay. Um, it is not to mean that the relationship between those types of requirements and the elements of the structure, but we are basically talking about the type of requirements that are actually going to enable the specification writer to be efficient. Yeah. So we need to the specification writer needs to know what types of requirements it's going to handle. Then you have the designer that also needs to know the requirements that are actually going to correspond to the design issues. We have some cases, for example, the internal interface requirements and maybe other quality requirements that might be corresponding to those specific design issues. So what I'm going to focus on in this paper or in this lesson is the types of requirements that are presented. What are the significances of each of those requirements to the analyst role, to the specification writer role, and to the designer role. So the first type of requirement that I'm going to talk about is the state or the mode requirements. And when you look at the state of the mode requirements, uh, actually contains the states that are required, and also or the state, or we can say the state also means the mode, um, or the transition that is actually required between maybe one state to another state, or one mode to another mode. Okay. Or maybe the response that actually is the system is required, maybe as a direct consequence of maybe a transition. Now we may be asking ourselves, what is a state? Now basically, I define a state as a condition of something, that maybe is required or is permitted. A mode, if we look it in this context, is actually related to the group of functionality, maybe for a particular purpose. For example, the mode of operation. Now, what is the significance of the state or the mode requirements to the analyst, or to the requirements analyst? Okay. Now you need to remember that both states and modes analysis is performed early in early stages in the requirements analysis, and this is going to have a contribution to the process of capturing any missing requirements, and also to the process of making sure that we validate the requirements that are available. Now we have the state and the modes analysis that is going to deal with the big picture that is actually required or permitted into what dynamics that system is extending to. So when we look at analysis, is actually a high return on the investment analysis, because we need to the person needs to skillfully use those states and those modes. So the requirements analysis needs to look at things like how to reduce the word count, how to increase clarity of requirements specification, and all that. Now again, the state of the mode requirements have this significance to the specification writer. Okay, because how this particular writer is going to deal with these states and modes specifications can actually influence on the effectiveness of that requirement specification. It can determine how effective the requirement specification can be. So we have some of the older requirements and standard that have been directed. Maybe it has brought in many damaging practices in terms of the states and the modes aspects of the requirements and their specifications. So how he is going to deal with them actually will contribute to how effective the specification is going to be. Now, to the designer, the states and the modes requirements, they have something we call soft influence, okay? Or we can talk about some effect. Now, it is because the designer is oriented to the bigger picture of the system. His orientation is actually on the bigger picture of the system. So he is actually oriented in the conceptualization of any solution available and what alternative do we really have in that. Let's move to another type of function, that is the functional requirements. And the functional requirements, simply in layman's language, they are going to tell us what the system is required to actually do. Now, the functional requirements have this significance to the requirements analysis. Now, since they capture and validate the functional requirements in a functional analysis, we have maybe things like the development of use cases. So when we have a requirement, when we have the requirements analysis discovering maybe a functional requirement, the analyst is going to look for maybe any associated measures and even values of performance that are required to that function. So after checking at any associated measures or values that are associated with that particular function, then he's going to iterate, or he's going to rest of scenario analysis. That is now looking for the requirements of other types. Then again, the functional requirements to the writer. What we need to know is that for the writer, we have the functional requirements that are placed in functional and performance requirements as part of the requirements specification. So he needs to know these are functional, or maybe these are performance requirements. He needs to specify them in that requirement specification document. Then we also have we have to the designer. So if we need to have a structural solution, then the functional requirements needs to be actually present at any point into that logical design. So making sure that that logical design contains all the requirements and corresponds to actually the requirements at hand. So we have another type of requirements known as the performance requirements. Now, the performance requirements is going to state. Remember, we said functional requirements state what the system is supposed to do. On the other hand, performance requirements will state how the system, or how well the system is going to do what it is supposed to do. In other words, how well is it going to perform the functional requirements. Okay, so these requirements are actually significant to the requirements analyst, because if the requirements analyst is going to find performance requirement that are not corresponding to without corresponding to the functions, then here the analyst is going to get and is going to find an incomplete requirement. That requirement will not be incomplete. So the analyst needs to find the corresponding function, then take that function, bring the function and the performance together in a complete statement of that particular requirement, so that now we have both functional and performance requirement are defined and clear. To the specification writer, we need to understand that the specification writer is going to keep the function and the performance together, but structurally. So you have he does not actually place the functional requirements maybe in one section of a requirement specification and performance in another. Yeah. So if he's going to do that, then we are going to have a duplication or maybe an ambiguity of those particular requirements. So it is a preference to the specification writer to actually press the function and the performance it is associated with and the required measures and values of that particular performance in one expression of that requirement. So it is not a requirement to fly and another requirement to fly at a certain speed. That is supposed to be one requirement. To the designer is going to achieve what we call the required function and associated measures of values and performance from the first acts. That is actually from the conceptualization of solution alternatives. Now this is through the complete designing process in the details that are actually required for implementation. So he's going to be subjected or will subject the measures and values of performance that are actually required to those to the performance and functions, as well as to the to the performance requirements as well as to the functional requirements. So we have things like thread analysis, we have iterative analysis that are going to actually to be used in this case, okay, to actually reduce any possible risk or any possible failure in terms of achieving the performance, and to make sure that we have optimized the designs, we have minimized errors, we have minimized the chances of risks occurring. Then we move to external interface requirements. These are type of requirements that are going to look at maybe the characteristics that are actually required maybe at a particular point or maybe at a particular region that where we are connecting the system to the outside world. Environmentally, what are the characteristics that are actually required? For example, which location, which geometry. We are talking about what inputs we are going to take from the environment and what outputs are we going to release to the environment by name, by specification, and even allocation of maybe signals, etc. Then we have the significance of these external interface requirements to the requirements analyst. So for us to understand that significance, we need to put ourselves at par with the fact that it is the work of the requirements analyst to capture and even validate the external interface requirements, bring them in a context analysis, okay? And he's also the one who is going to complements this particular capture and validation using what we call the rest of scenario analysis, or maybe passing analysis, or out of range analysis, okay? When we are dealing with things like data-oriented systems, then we have the entity relationship attribute analysis that is done. Again, to the specification writer, the specification writer is going to place those requirements to have what we call external interface, maybe in a particular place in the requirements specification. And these requirements on that particular internal interface are going to be placed in another specification, in the requirements specification. So he's going to decide whether to specify maybe this particular requirement, a particular set of requirements in an interface requirements specification that are actually involved in by reference, or to specify those external interface requirements within the subject system requirements specification, or maybe in the software requirements specification each of these two cases that we have here, we have this same person deciding if he's going to organize the requirements on maybe on interface alphabetically by parameter, or maybe according with some level of abstraction, depending on maybe on OSI, on models that is being used. For example, if you're talking about the OSI 7-layer model, so we need to understand here, and we need to realize that requirements on an internal interface design requirements, and even the specification writer, uh, they need to be treated accordingly. So to the designer, um, um, what is not actually included to the external interface requirements is something that can be discredited by the designer, or it can also become a subject of the interface, the external interface design. So you have the external interface design that must be or should be actually consistent when we have the two ends of interface. But in most cases, we have that external design that is going to assume the status of requirements. For example, when you have the overall design to meet the requirements is actually maybe a baseline prior to the release into the production, or maybe the construction, or maybe the acquisition. So it is somehow a unique aspect that is relating to external interface requirements. So we have the design manager here that is actually making sure that he is going to manage that transformation, so that at any point in time, we have complete and accurate answers to questions that are actually asked. Questions like, what are the characteristics that are required for this particular interface? Then we have environmental requirements. So these ones are going to limit the effect that the external environment is going to have on the system. Okay, and also look, they're going to limit that the effect the system is going to have to that external environment. So they are significant to the requirement analysis, because we have the requirements analysis who is going to capture and validate those requirements in context analysis, also in rest of scenario analysis, though they are going to be conducted iteratively with the functional analysis. So to the specification writer, environmental requirements here are actually a unit of structure in the requirement specification. So they have three related concerns for a physical system. And the first one is the classes of environment. So if there are any here in terms of storage environment and operational environment. Then we have the other, which is for this particular class. The other concern is actually for this particular class, or for any of the specific classes, we have the set of parameters, the set of environmental parameters that are going to be applicable, or they're going to really apply to that class. And the last concern is that for each of this class of any environment, then you have the applicable environment or environmental envelope, or maybe a set of envelopes that is going to range from environmental parameters that are going to apply simultaneously. Then we have their significance to the designer. Here we are going to look at, with respect to the environmental requirements. Yeah. So we don't have any unique and generic design process issues when it comes to the designer. So we have the other type of requirement, which is the resource requirements. And the resource requirement is going to limit the usage, or maybe the consumption uh, of external resources by the system. We're going to limit the system from consuming externally provided resources. And here, these type of requirements have the following significance to the requirements analyst. Now, we need to know that the requirements analyst will capture the requirements, the resource requirements, in both context analysis and rest of scenario analysis. Again, to the writer, the resource requirements needs to correspond to maybe a section of the requirements specification. So there is that requirement specification. There is a section that corresponds needs to correspond to these requirements. To the designer, then here we are going to talk about the effect of any impedance in the supply of maybe an external provided resource, it is actually going to affect how that system is going to behave. So the designer is going to conduct what we call resource coupling analysis, as he will be considering the external provided resource. Then we have the physical requirements, and for the physical requirements, they are going to we have um, it is going to show us what are the properties of matter or the physical characteristics of that particular system as maybe a whole. For example, in terms of mass, in terms of dimension, in terms of volume, in terms of center of gravity, in terms of surface coefficient of friction and density, etc., etc., etc. Then these types of requirements have this significance to the requirements analysis. Now, it should be noted that the requirements analyst will have to capture resource requirements in several analyses incrementally, so that's why it's important to him. Then you have the writer. Uh, for the writer, we have physical requirements that needs to correspond to a section in the requirements specification. Then to the designer is going to look to the physical requirements. And one thing you realize about the designer, we don't have any unique or maybe generic or maybe design process issues in terms of the physical requirements. So there are other quality requirements that are in there uh, that are going to show us, or they are going to state the quality of the system that is required. Okay, so they are not they are not a design requirement, or they don't belong to any of the requirements types that I have mentioned. So the other quality requirements, they have significance to the requirements analyst, because when we have a number of analyses that are actually going to contribute to the capture maybe and validation of some quality requirements, then the requirements analysis must rely on the stakeholder value analysis to make sure that you capture and you also validate the requirements of that particular type. Now to the writer, the other quality requirements needs to correspond to a section again in the requirements specification. To the designer, you have the other quality requirements that are profound. They're significant to the designer, because we have the whole board of knowledge that actually applies regarding engineering to achieve that quality results that is actually expected. So we have the design requirements that they are going to give us directions in terms of the design. And when you talk about design, we are looking at the internal of the system. We are looking at also the external of the system. For example, they can say the system needs to be built this way, or it doesn't have to be built this way. So the design requirements, they have significance to the requirements analysis, because uh, um, we just have the requirements that are already existing, but then they are identified, then validated in a design. Yeah. So that can give us some substantial reduction in terms of the number of design requirements, because we can have many requirements that needs to be replaced by others. So we also, to the writer, now how the specification writer is going to deal with those requirements can have an effect on the quality of the requirements specification, especially when if the design requires the requirements are numerous. So we have the requirements, the writer here, that should actually apply some sound principles in making sure that he's organizing maybe the structure of the requirements specification to have the design requirements incorporated in them. So to the designer, we have invalid design requirements. Yeah, that can actually cause maybe grief, or forcing the designer to redo things, or to do some things that are not reasonable. So the designer makes decisions based on those requirements, on what to include and what to really eliminate. Yes, and I'm not going to go so far today. So let's compare the different categories of requirements in information systems. But before that, we need to talk about data and data conversion. So we need to talk about what is data. We define data as raw facts and figures um, that are actually collected for analysis. Another thing that you need to know about data is that they don't have specific meaning for interpretation. Okay, data do not have specific meaning to for interpretation. So here we are talking about the quantities, the characters, or maybe the symbols um, on which we can perform some operations, either via a computer. They can be stored, they can also be transmitted, whether electronically, that is using electronical signals, or maybe they can be recorded on some magnetic, optical, or mechanical recording media for transmission. Then there are things that are known, or maybe they are assumed as facts. So data form the basis of reasoning or maybe calculation. Any calculation you make, it is based on some form of data. Any reasoning you make is made on some form of data. We need to look at something called data conversion. So data conversion is simply the translation of data from one format to another. The translation of that data from one format to another. Yes. So that is data conversion. The way in which um, a good example can be the way in which many of us can consume maybe some entertainment content. Let's assume comedy. There's that guy who would want to really watch a video, another one would want to have a music, an audio file, etc, etc, etc. So why do we have data conversion, or what is the goal of data conversion? Of course, we are converting data to prevent two things. One, data loss, and number two, corruption. We are making sure that we are going to prevent corruption by making sure that our data meets the standards of integrity, and also they are in embedded structures. Okay. Now, to do that, you need to make sure that the format of the data is supported by the destination format also. The destination format is actually supporting the same features the data is into. If we have a source format that is not supported by the destination format, then we must make sure that we convert that format correctly, yeah, so that now we are able to read and modify and also analyze that data where we are actually sending it. Now, there is some confusion in terms of what data conversion is. So what I have told you is data conversion. We are converting data from one format to another. And we said the aim of that is to make sure we are preventing data loss. We are trying to maintain the data integrity. But there are a number of things people consider as data conversion while they are not. And that is why I have the title, What Data Conversion is Not. So often at times we confuse um, this data conversion with some processes like data migration, data transformation, and data cleansing. Those are four different things: data conversion, data migration, data transformation, and data cleansing. So data conversion is data conversion, and data mining, data migration, data transformation, and data cleansing is not data conversion. Let's look at data migration, for example. Okay. When we do data conversion, we are changing the computer data from one format to another. But when we are talking about data migration, we are moving. In other words, we are transferring the entire, it can be a database or program, from one location to another location. We are changing the location, but we are preserving the format. When we do data migration, we change the location, but we preserve the format. Sawa. Now, at times, in data migration, we also do data conversion, or maybe data transformation, or data cleansing. But the two are not the same thing. Now, data transformation, uh, um, while in data conversion, we are translating or we are changing the format of data from one type to another. In data transformation, we are actually changing the data presentation. We are changing the data presentation. How the data is presented, that's how we are changing. The format does not change, but how the data is presented is what changes. And I've shown you an example. For here, we have this transformation. So it looks like we have 4, then string A, this one is into brackets. Then when we come here, you see, now we are changing this 4 bar. Now this is how we really present that data is a little bit different, but we have the same format. Now we have data cleansing. Now data cleansing is simply trying to find some inaccurate, repeated, and incomplete data. Then you remove. Removing inaccurate, repeated, and incomplete data. That is cleansing. So normally we have this procedure happening after we have converted data, or maybe after data transformation, or maybe data migration. Okay. That's important to really understand. Now, what are the types of data that can be converted? Now, for you to convert data, you need to understand the first thing is that you need to understand the different types of data that you can convert. So we have programming languages that rely on data types that are going to tell the compiler or maybe the interpreter how this particular data should be used. So whatever data type you actually use in such a programming, in such program, is going to determine what operations that can be done on that particular data. For example, if you're using a string as a data type, you cannot then start multiplying strings. It is going to limit you from performing some arithmetic operations on it. But when you are dealing with numeric data, maybe a number, then you will be able to do all those other types. Okay. Okay. So we have a primitive data and we have the composite data. We have those that can be converted and those that cannot be converted. For example, the compiler languages, we have the C language, and the Java, for example. You can convert. Then we have the code pages. We have code pages that are actually specific to some operating system. For example, the ASCII and the EBCDIC. Then we have some document types that include different text, maybe text, audio, and video file formats. So for you to be able to understand those different types of data that can be converted, you need to look at some real life applications of this data. For example, you have the healthcare industry that is going to heavily rely on some high level quality of historical conversion to ensure that we have some health records. Yeah. So this particular industry, the healthcare industry, is going to use frequently the data conversion, because here we have transitions between the electronic media records, record systems happening. Then we have the telecommunications and networking companies that are going to base on vendor agnostic input. We have output that can only be achieved with maybe data conversion. Then we have the scientific community also that is going to research and even merge findings of complex studies that is conducted in some similar formats. We have insurance companies also handling data.